between those two functions? What's the structural similarity? What's the structural similarity? What's the same about both of those lines?
Both equal y.
They both equal y. This is the key here. They both equal y. Y is isolated. Is it possible to write a phrase where y isn't isolated? Absolutely. So y is isolated. We have been differentiating functions where y has been isolated the entire time. We have y as a function of x. Is it possible to write things that aren't the same as that? Absolutely. Point slope would be a function. Yeah, every function that we've looked at so far, the definition of a function so far has been y equals something in terms of x. Absolutely. So it's hard to come up with a counterexample because we've only limited what we've looked at to functions. Two functions. Let's say we changed it a little bit. Let's say we changed it to this. Let's say I changed it to this and said, given x squared plus y squared equals 4. Is that an explicit function? Is that explicitly written? Is this explicit? Based on what I just said 5 seconds ago. Is it explicit?
No.
Why not?
Y isn't isolated.
Y is not isolated. If I asked you to make a graph of that, how could you go about making a graph of that? What's your default way of doing something to make a graph if you have no idea what to do? What can you always do? What can you always do? It was the first thing you ever did with functions.
Solve for y.
Nope. Not solve for y. Nope. Not solve for y. Let's say, what could you do without solving for y? What do you mean? Yeah, go with that. What do you mean?
Or like take.
If I just want a picture, I don't want the function, I just want a picture of what this looks like, what could you do?
Plug 1 in for x and solve.
Solve for what?
Solve for y.
Exactly. So what are you making if you're doing that? What are you making?
One of those little charts.
Yeah, what's that called? Make a table. Make a table. So you have, I gave you a window to work with right there. What are the x values in there? What are the x values? Oh, there's from like -4 to +4. But you might not want to use -4 and +4. What would be some good values to test, do you think? What x values do you think we should write for our table here? X and y. What's a good x value? What are some x values we should try? 0. That's a good one, yep. What else? How about 1 and 2? And how about what else? -1 and -2. Fill that table in for me. If x is -2, if x is -1, if x is 0, if x is 1, and if x is 2. Fill that table in for me and tell me what's y going to be. 0, right. If x is -1, what's y going to be? The square root of 3. If x is 0, what's y going to be? Come on. If x is 0, what's y going to be? Just take a look. You don't need to do math. Everybody, there should be no algebra. You should be able to do this in your head, okay? Take a look. Everybody look up. If x is 0, what's y? 2, yeah. If x is 1, y is going to be √3. And if x is 2, what's y going to be? 0. So what do you do once you have those points? Plot them. So you have -2, 0. You have +2, 0. You have 0, 2. What does this actually look like when you plot it? Yeah, that right there is the point. What point is that right there? That is 1, √3. And what point is this right here? And it's not a parabola. Actually, it's close to a parabola. -1, √3. Anybody know what that is? It's not a parabola. It's not a parabola. I'll give you a hint, everybody. There's actually a whole nother set of answers you could have answered these with.
I don't like that.
You don't like that? So what about these answers right here? There's a first y value and a second y value. X squared plus y squared is 4. Let's look at 0 here. Let's look at 0. When x is 0, y is 2. What else could y be? Yeah. Y could be -2. This could be -√3. This could be -√3. And this could be, well, -0 is the same, right? So if you plot all those points, what do you end up with? What do you end up with? Someone said it.
A circle.
You end up with a circle. So what point is that right there? That's 1, -√3. And what point is this right here? What point is it? What point is this right here? -1, what? -√3, right. So here's the thing. Is that a function? Is that a function? There was something you learned, I know you learned many times over again. Is that a function?
No.
Why not?
It doesn't pass.
It doesn't pass the
line test.
the vertical line test, right? It doesn't pass the vertical line test. So is this a function right here? No, it's not a explicit function. It's an implicit function, so that can violate the vertical line test. They can go back on themselves. So if you're ever lost as to how to graph something, what can you always do to graph something to get a basic idea of what it looks like? What can you always do? Plot points. Is that a perfect way of graphing something? Is that a perfect way of graphing something? No, it's not a perfect way, but can you always make a table? If it's x squared plus y squared equals 4, if I want to solve for y, what do I do first?
Subtract the x squared.
Yes, so y squared is equal to 4 minus what? X squared. Now what do I do to both sides? What do I do to both sides? Yeah.
Take the square root.
So I have y is equal to the square root of 4 minus x squared. If anybody writes 2 minus x, I will be very sad. You have to take the square root of the whole thing. The square root of the whole thing. There's actually something that's missing right there. Can someone tell me what's missing?
Plus or minus.
Plus or minus. When you take square root, it has to be plus or minus. So here's the thing. Y equals, sorry, wrong color. Y equals the positive 1. Where's that going to be? And then there's y equals the negative 1. Where's that going to be? Well, I kept the colors the same for a reason. The blue part is when y equals positive the square root of 4 minus x squared, and the green part is when it equals negative the square root of 4 minus x squared. You have to have two functions glued together. So in this one, if I wanted to find the slope right here, do I want the positive 1 or the negative 1? Do I want the positive 1 or the negative 1?
Negative.
Is this positive or negative?
Positive.
So which one do I want to work with if I want to find the slope there? The positive one. Everybody sit down, everybody. Thank you. So let's look at the positive one. The positive one, that's y equals the square root of 4 minus x squared. If I wanted to take the derivative of that, what should I do with that square root? What should I turn it into first? Square root is what power, everybody?
1/2.
1/2. So it's y is equal to 4 minus x squared to the 1/2. Can someone tell me what the derivative of that is? Someone else? Someone else? Kira.
It's 1/2.
1/2, yep.
Times 4 minus x squared to
Two-
the negative
1/2 times what?
times negative 2x.
Yes, because of the chain rule. So if I wanted to know what the slope is at 1, what do I plug in for x now? 1, yeah. So if I do y evaluated at 1, this is y prime now. There's y prime. So I get 1/2 times 4 minus 1 squared to the negative 1/2 times negative 2 times 1. Can I simplify this? Uh-huh. What does to the negative 1/2 power mean? What does to the negative 1/2 power mean? Come on, kids. I know it's Saturday. I know it's painful for you to be here. So what do you end up with? Negative 1 over the square root of 3. So the slope of that tangent line, did we expect it to be negative? Yes. So what was the slope here? Y equals negative 1 over what? Root 3. We needed to isolate and then take the derivative. What does this mean? A to the negative 1 over 3. What does that mean? Can someone translate that for me? Yeah, Connor. 1 over the cube root of a. Exactly. What does x to the negative 1 over n mean? 1 over the nth root of x. You have to remember that. You have to remember that. You have to remember that.
Negative 1/2
Times.
negative 2x.
Yes, exactly. Now there's some negatives that cancel there, right? Can we simplify that a little bit? So what does y prime equal? That cancels with that, right? And the negative cancels with negative. So you have x times 4 minus x squared to the... What do we need to plug into that? What value for x do we want to plug in now?
1.
1. So we do y prime evaluated at 1, and we end up with 1 times 4 minus 1 squared to the negative 1/2. That's going to be 1 over what? 1 over what? You can do it. 1 over what? What's 4 minus 1, everybody?
3.
What does negative 1/2 power mean? We just talked about it.
Square root.
Yeah, so it's going to be 1 over the square. Oh, look. Is that the exact opposite of... Is that the positive version? So what's the slope of this line? 1 over root 3. The key is, what did we have to do first in order to do this? What did we have to do first? I'm literally circling it. What did we have to do first? We had to solve for y first. We had to solve for y first. This was relatively easy. Here's the key. Is it really easy for me to change a little bit about this and make it impossible to solve for y? Yes. Here's the key lesson you need to learn today. It is not always possible to solve for y, at least not easily. What do I mean by that? It could look like this instead. Y cubed minus xy minus 6. That's a cubic. Do you have any real good way of solving for y right there? No. There's no good way to solve for y. So the key is sometimes you can't solve for y, and that's what we're going to learn how to deal with right now. It's called implicit differentiation. Implicit differentiation, because this is, what kind of function is this? This is a what? What kind of function is this? It's a cubic implicit function. What was the other type of function that we dealt with exclusively up until this point? We dealt with explicit functions. Now we're dealing with what type of functions? Implicit functions. So if you can solve for y, is that nice? Yes. But in this case, can you solve for y?
No.
No. Can't solve for y. Not very easily, actually. It is possible, but very, very hard. So what do you do instead? What do you do instead? Well, and say we have f of x cubed minus x times f of x, we don't know what the function is, equals -6. All I've done is I've replaced y with f of x. Are we okay with that? We don't know what it is, but we're just going to put it as a placeholder. If I was going to do the derivative now, I'm going to do the derivative right now on both sides. Let's look at each piece. If I differentiate with respect to x, if I differentiate this with respect to x, what do I bring to the front? Zach, what do I bring to the front? 3. So I end up with 3 times f of x to the what power? To the what?
2.
To the 2. But then because of the chain rule, what do I have to multiply by?
Times f of x.
Times, not f of x, times...
Oh, x.
No.
No, 1.
No. What's the derivative of f of x?
F.
No. The derivative of f of x is the derivative of f of x. We don't have a function, right? If I just wrote on the board, ready everybody? Here's h of x. What's the derivative of h of x? H prime of x.
Okay.
If I don't give you a function, you just write derivative, right? So what rule, everybody, what rule did we just use right now? Chain rule. That right there is because of what rule? The chain rule. So now, what rule do we have to use to differentiate this right here? What rule? Be very careful. What rule do I have to use? Product rule. It's two functions. It's x and another function. It's x and what? Another function. It's x and another function. So let's do this now. What's the derivative of x in terms of x? That's the nice one. What's the derivative of x in terms of x? 1. It's the derivative of the first times the second plus what? The first times the derivative of the second. Do we have a function for x? No. So what's the derivative of f of x? What's the derivative of f of x? F prime of x. What's the derivative of -6? Who said it? 0. So what rule did we use to go from here to here? What is that? The product rule. So let's pause right. Yes. Yes. So what do you end up with? F prime of x is equal to what?
F of x
Over what?
3f of x squared
3f of x squared minus
minus x.
x. But do you remember the first substitution we did? What does f of x equal? What does f of x equal?
Y.
It equals y. That was the first substitution we did. So what can we plug in now? Y. So we have f prime of x is equal to y over 3y squared minus x. Guess what you just found, everybody? You just found the derivative. But the key difference here is, what's in your derivative that it hasn't been in your derivative before? What's new? What's in your derivative here that hasn't been in your derivative before?
Y.
Y. When you do things implicitly, you can very likely end up with y in the derivative. Here's y. Do you remember the circle, everybody? At x equals 1, how many points had x equal 1? There were 2 of them. So when you did the derivative, you needed the x value and the what? You needed the x value and the y value. Are you starting at the top part of the circle or the bottom part of the circle? You need the x and y. So in this case, you need x and y to find the slope of the line at a given point. Because this case, can this double back on itself? It can double back on itself. So let's look at this. What was that original function we looked at? We had x squared plus y squared is equal to what?
4.
4. What was the first step I gave you for implicit differentiation? Let y equal what? It was the first substitution we did. Y is equal to? Some function in terms of x. So we have x squared plus f of x squared equals 4. Now we take the derivative in terms of x. What's the derivative of 2x, Jen? Sorry, what's the derivative of x squared?
Oh, 2x.
2x. Can someone tell me what the derivative of f of x squared is? Be real careful. What's the derivative of f of x squared?
2 times f of x
Times
times
f
prime of x.
prime of x. Because of what rule is this? The chain rule. Yes, Nick. And what does it equal, everybody? This is really important. This is the most common mistake people make on this. What's the derivative of 4? 0. What do people do all the time on implicit differentiation?
Make it 1.
They make it 1 or they keep it 4. And it messes the whole thing up. Yes, Nick?
What did we start with? You should all just look
We started with x squared plus y squared is 4, the circle. This is a circle with radius 2. We started with this one right here. I'm doing a new problem right here. So now, what do we want to isolate in here? What are we trying to isolate? What are we trying to isolate? What are we looking to find? What did we find before? F prime of x. So how do we do that? We subtract 2x. Can we subtract 2x? Is that okay? Are we okay so far?
Why don't we take the second derivative?
Substitute in and make it 3y squared y prime plus 2 times y plus x y prime equals 0. Is that a little easier to write?
What happened in the parentheses?
What happened to which parentheses? What,
After the
what's that called? What did I do to get from that 4th line to the 5th line? What did I do to get from here to here, everybody? What's that called? Come on.
algebra.
Distribute. Remember that word, everybody? Maybe? Vaguely. So what do we end up with here? 3y squared y prime plus 2xy prime is equal to what? Negative what? 2y. What do I factor out now? What do I factor out now? Y prime. Nope, not equals. Y prime times 3y squared plus 2x, right? 2x is equal to negative 2y. And you have y prime is equal to what? Negative 2y over. Yes, there it is. There's your answer right there. There it is.